I'm Oleg Zhurakousky. I have an interesting history in Spring organization. I came, I left, I came again. It's addicting company. You can't just leave it and then stay out forever. You'll come back eventually. I'm one of them. There's few of us like this. But I am currently back in the days I was helping Mark Fisher to do Spring integration. But now I am tech lead for Spring Cloud Stream, and as recently Spring Cloud Function as well. So I'll try to use this time to cover, well, mainly Spring Cloud Stream, but there's going to be a significant portion of it dedicated to Spring Cloud Function and some of the new things that we are working on or thinking about. So, which means this slide, so not just working on, but also thinking about. So you may see something that you may never see again, or you may see something that you may see in the future installments of the frameworks, plural, I guess. So this is pretty much the scope for the presentation. So we're going to define some of the buzzwords that we currently use. And again, like for example, cloud, right? If I ask everybody in the room, can you just tell me what the cloud is? I probably get like 50 different answers, right? So at least for the scope of this presentation, I'm going to give you my version, and whether you agree or don't, I really don't care. So, but anyway, before I get any further, let's just do a quick show of hands. Who is using Spring Cloud Stream, or who is familiar with Spring Cloud Stream? Very nice. So about 25–30% data flow. About a little less. Spring Cloud Functions. A few. Spring integration. Rock and roll, yeah. So the reason why I mentioned these 3 or 4 or 5 projects, because they're all intertwined together, and we kind of I'll try to, during this talk, to kind of map and connect each and every single one of them so you understand their relationship with one another. But like I said, this is my agenda, so we're going to talk about the cloud, event-driven architecture, streaming. We're going to bring everything together. Then we're going to talk about what's new in Spring Cloud Stream 2.0. We're about to release 2.1, so you're going to see a lot more than what you would see 6 months ago. And we're also going to talk about what's next, what are we thinking, right? So you're going to get a preview into our minds. And by the way, I am usually not the type that waits till the end for the questions. I prefer them in context of what you're listening. So although the spotlight's on me, I'm usually looking around, so just raise your arm and I'll stop and I'll let you ask the question. Now, people over there, I can barely see you, so you would need to like really wave. There I'm fine. So cloud, here's my version of the cloud. It's an ecosystem that integrates platforms and middleware into one cohesive hybrid runtime. Anybody disagree? I mean, I don't care, but but this is kind of like a vague, but at the same time, all-encompassing definition of the cloud. Basically, it's something out there that gives you, basically it outsources infrastructure concerns to the cloud provider, so you no longer have to worry about installing your own database or installing your own messaging system. You're just simply using whatever type of connector architecture the cloud provider provides and just connect to an existing system. It's out there somewhere and it does what it's supposed to do. So it provides a mechanism for application services, we call them clients, to interact with cloud services. And it's naturally event-driven, right? So, events. So events are everywhere. This is a representation of a state change, right? So event is one sort of like important attribute of an event. It's always in the past tense. If you see event, it already happened, right? So I like how John Schneider kind of points out to some of the improper method names, like time, now. Well, that's not now, it's already happened, right? So anyway, events are always in the past, so they're delivered in the form of a protocol-specific records using some kind of a messaging middleware. And I guess what I'm leading towards is that events are just a piece of data, right? And to me, you obviously hear about messaging and messages a lot, right? And message is nothing more than just a representation of an event. Message is the simplest structure you can possibly imagine. It's a tuple 2, right? It's a key value pair. It's the payload and metadata, meta information. So it's just an envelope with something in it, right? And it basically allows you to send a piece of data and also some kind of a description about this data, right? There's many different delivery mechanisms, and we need to be able to both interpret as well as connect to this type of delivery mechanisms. So Stream is an extension of an event-driven architecture, because in Stream, there's really not much changes except for the programming model itself, because you're defining a graph of operators, you're injecting events in it, and then you execute the graph, right? So it's the same as if you just simply writing a handlers and creating a framework that will invoke one handler, then another, then another, then another. So it's just a difference in the programming model, but it's also a difference in how you can possibly scale your application, because you're simply defining a graph, and graph defines what should happen if this happens successfully and if this happens successfully. So it kind of defines your pipeline. Now, how it's going to execute in parallel or concurrently, that remains to the graph implementation and some of the settings that you may set, right? So it allows you to kind of be a bit more flexible with your functional and non-functional requirements. So, and that's kind of an example piece of code like what you would, kind of a monadic style of expressing your event-driven pipeline, so to speak. So now, Spring Cloud Stream. So before we get into Spring Cloud Stream, so I kind of gave you a quick overview of sort of the problem domain, right? So now let's talk about the Spring Cloud Stream as a framework. And again, for those of you who are already using it, maybe it's going to be a refresher, or at least you'll hear my view of Spring Cloud Stream. For those of you who are new, hopefully it will open this as a framework of choice for your future application development. But before we get there, again, I mentioned earlier Spring integration, because that's where pretty much everything started. Actually, I'll correct myself, because where everything started is with that book that was written by Gregor Hoppe and Bobby Wolf a long, long time ago. And when we were developing Spring integration, that's pretty much became a specification for Spring integration. In fact, it still pretty much is. When you open up the book, when you look at the patterns, their names, and you go to Spring integration, there's a very good chance that you will find that same transformer, that same service activator, that same filter, channel, and everything else. So basically, we're talking about pipes and filters architecture. That's the fundamental architecture of any messaging system. You have pipes, which could be any kind of which could be backed by any kind of messaging middleware or not, like in Spring integration, internal channels, right? And then you have filters, which is basically your transformers, services, and whatever. The main point here is that none of the filters are aware of one another. The pipe provides a decoupling, a naturally decoupling mechanism between the two filters, right? So each filter basically becomes either a subscriber or consumer or both. So, and in other words, when you look at the diagrams of pipes and filter architecture, they're all simple and they're always going to be the same. But whether this queue, that channel, is going to be backed by a really distributed remote system like Kafka or Rabbit, or whether just an internal channel, it's unknown from the diagram. Why is this important is because you can actually use frameworks like Spring integration to model a lot of your problems before you get it into the true distributed world with the Spring Cloud Stream. And in fact, I mean, I won't have time to show it to you today, but if you're interested, I can at least explain how we did it in one of the clients that I was visiting not too long ago, where we modeled their entire problem in Spring integration and then really took that and re-implemented and reconfigured it using Spring Cloud Stream. So, so what's also important about Spring integration is that Spring integration is the underlying framework for a lot of the functionality provided by Spring Cloud Stream. So for example, like if you think about the binders, for those of you who are already familiar with Spring Cloud Stream, the binders for Rabbit, Kafka, Kinesis, and things like that, those binders are based on existing code provided by Spring Integration that provides the connectivity to those systems, whether it's a message listening container, whether it's an outbound adapter. So in other words, we basically reusing the existing artifacts from Spring Integration to connect to those systems. It's also important to understand that within, when it comes to the binding, which we'll see in a second, we're also utilizing Spring Integration channel mechanism, which means that if you're familiar with Spring Integration, which I've seen most of you kind of are, then Spring Cloud Stream, and at least at its current iteration, is going to be like a walk in the park because you're simply receiving and sending messages to a channel. We provide the binding of the internal channel to an external destination. But that's already done by the framework, so you don't have to worry about this. Anyway, so it's all at the very core is Spring Integration. Spring Cloud Stream is basically the framework that kind of wraps, not necessarily Spring Integration, it uses Spring Integration, but it's a framework that presents the same concepts that Spring Integration does within the sort of a single JVM and brings it out to the distributed world. You're still thinking in terms of pipes and filters, but you really rarely worry about the pipes themselves. You just simply worry about the filters. You're implementing a service, a microservice that does things. Now, for those of you who are already familiar with Spring Cloud Stream, you know we handle, like, we have this conditional things, we have a lot of different things. Like, I'm not going to touch on that today because I prefer to look at the microservice as, and again, I want to define what it means to me. It's a simple service that does one thing and one thing only, and does it well. It's not a messaging application that does, internal routing, conditions, and stuff like that, because that's really kind of a different discussion. So for me, you're only writing a filters, the microservices, and Spring Cloud Stream allows you to bind these microservices through a variety of different messaging middlewares together into a cohesive flow. And in fact, the other framework that I mentioned earlier, Dataflow, Spring Cloud Dataflow, actually helps you to do what I just said. So in other words, you can write microservice A and microservice B and put a queue in between and create your own configuration, send message to a queue, receive message from that queue, and all of a sudden you have some kind of a pipeline going. Or you can skip doing all that and just use Spring Cloud Dataflow and write a single command, and it's all going to be the same. So in a way, it's kind of important to understand not just how Spring Cloud Stream operates, but also how Spring Cloud Stream operates within the context of other frameworks that are provided by Spring. So again, it's a boot-driven integration with messaging brokers using the binders. It leverages native features of those brokers. For example, when it comes to Kafka, so the partitioning, the consumer groups, those are features provided natively by Kafka, so we just simply integrate with those features. But for example, in Rabbit, there is no such thing as a consumer group. Well, but in Rabbit, there is an exchange and there's internal routing mechanism, which means it was easy to implement our artificial concept of a consumer groups. The point for you is that we gave you two different binders with identical functionality pretty much, right? How we did it, it's our business, but you have consumer groups, you have partitions, whether you're using Rabbit or whether you're using Kafka. So in other words, either we use native features or we try to implement based on what's available within the messaging system. So like I said, partitioning consumer groups, honors application configuration by the underlying framework. So for example, and I'll show it to you in a second once I get to the demo part. For those of you, again, who know, there's an annotation called Stream Listener, but we will also honor Service Activator because those are native annotations from Spring Integration, which means transformer, filter, all of those annotations are going to be wired. If you have Kafka, then Kafka Listener will be honored as well, and so on and so forth. So in other words, if you already have an existing messaging applications, for example, that are already using Spring Integration, migrating them or partitioning them into Spring Cloud Stream would be relatively simple because we honor the same contracts that you already expect to be honored. Any questions so far? All right. So some of the features that are important to mention, transparent content type negotiation and argument resolution. So when you're writing a handler, the important part is that you kind of have to understand that as a developer, you thinking in terms of the main object. So you want to receive a person. You don't want to receive a string, a JSON string that represents the person, unless that's what you want, right? But if you don't, you want to receive an object that you want to be dealing with, right? You want to be able to also send an object, right? And you want something to convert it, because I cannot transmit person on a wire. I have to transmit it. I have to convert it to a wire format, we call it, right? So we provide all that negotiation and conversion, and we'll talk about it in a bit during a demo. So again, I already mentioned the ability to connect to a variety of different systems, and flexibility in terms of programming models. So, and recently it became just even more flexible than it was before, and we're going to cover it. So I'm kind of going to skip it right now, because we're going to do it during a demo part. And so it's a boot app. Our configurations are flexible. So again, I keep bringing up, like, nobody can force me to exclude the word XML from my presentation. I love XML. If it was up to me, I would still use XML, but there are definitely reasons for that. But actually, what I'm trying to say here is that it's entirely up to you what you want to do. If you want to configure your application using XML, annotation, or hybrid, we've done it both. So binders, we have streaming, K-stream binder for Kafka. And if you're interested in how that thing operates, Sobi Chaka, sitting right here. Him and Sabi, another guy, are going to be doing presentation tomorrow morning. But if you guys have any questions, I'm sure Sobi will be happy to answer them after the presentation, as well as any questions related to Kafka, because he's a project lead for Kafka Binder. So basically, Kafka Rabbit binders, and then community binders for Google, AWS, and Azure. So Artyom Bilan here, he's handling some of this community effort, or helping with the community effort, so you can also talk to him. Am I good at power delegation? Like, Glenn, what can I do for you? Like, data flow, that's the guy, yeah. So, and anything machine learning Christian, so you got everybody. And if you want to learn how to play guitar, Dave Turansky. So anyway, seamless integration with the rest of the Spring Cloud stack. That's important because, yes, the frameworks in Spring provide functionality that help you to do something. However, what makes Spring even more attractive is ability of individual frameworks to interact with other frameworks, especially with what Boot has done for Spring. So if you essentially can start adding to the stack, and through auto configuration, things are going to become part of your application. So like whether you want to collect metrics, and I'm going to show it to you today, Sluice, Spring Cloud Config, Circuit Breaker, and so many more, you can basically make those as part of your application by simply including those auto configurations in your class path. All right, and finally, before we get into the demo part, this is kind of like Sobi and I worked on it for a while. I mean, I was bouncing the ideas. This is like a one slide, that's what Spring Cloud Stream means to me. So you have this, on the right-hand side, you have this messaging middleware, Kafka, Rabbit, whatever. And then the binder is what provides the connectivity to that middleware. So the thing that you slide in the middle is your application. And that application kind of stays as simple as it could possibly be. It is not aware of any Rabbits or Kafka or AWS or anything else. It's just a Spring Boot app with a few extra annotations that we are actually thinking about kind of simplifying. So that's pretty much what Spring Cloud Stream is. So the benefit for you is that you just develop a Spring Boot app, you slap a few annotations on, and then the rest is getting taken care of by auto configuration. So you, and again, you go to, either you do it yourself, or you just simply go to start.spring.io and create a sample app, which will bring the appropriate jars into a class path, and that's pretty much it. So any questions so far? Demo. So now we're going to write some code. So first question, can you guys see the code? Should I make fonts bigger? Bigger. I see somebody is pointing. Good? Smaller? Anyway, I want to leave a little bit of real estate for me so I can at least navigate. So anyway, so as you can see, so what I'm writing is the simple Spring Boot app, right? We can discuss what's in the class path in a second. So it's a Spring Boot app, and right now, one important thing to understand within Spring Cloud Stream, we have these three sort of stereotypes, which actually map to the concept that we're going to be discussing in a few minutes of functions, which is a supplier, consumer, and function, right? So we have processor, source, and sink. And source is a supplier, sink is a consumer, and processor is a function, which means there's an input and there's an output. For sink, there's only an input, no output, and for source, there's no input, only output, right? So that's pretty much it. So, and the reason why we do that, we basically say we're defining that this application is going to be a processor, and through enable binding annotation, we're not only declaring that this is going to be a processor, we're also directing the framework. Remember I mentioned those channels? So we're also directing the framework to create channels and bind them to the external destination. And in this case, can anybody tell me, am I going to be talking to Kafka or Rabbit or AWS? No, the only way to tell if you look at the POM file, because there's absolutely nothing in the configuration that would be specific to one of those messaging systems. And that's kind of the important part for you, right? So, and this is my functional code that I've written. So basically a very difficult piece of code. Is going to uppercase the string. So right now, it's just a plain Spring Boot app, and if I start it, nothing will happen. So in order for me to make something happen, I need to oh, actually, no, I can do, instead of doing strings, I can do Okay, so at this point of time, I define a stream listener, and this is it. So I have an application that I can work with when it comes, basically send message to it and so on. So let's quickly run it. And right now, it receives the string, it outputs the string, but so here I'm in the Rabbit console. So I'm using Rabbit. And I'm going to, this is my destination. So I did provide a little configuration to avoid the anonymous queues, but I'll show it to you in a second. But I'm going to go to this queue. And so basically, I'm going to the input destination that is bound to the input channel within this application. And I'm going to say, hello, world. And I'm going to send the message. And the message was received. Obviously, we didn't see anything in the console, but I already bound it to an output destination just so we can, and it's already here, so I can just get messages. And you can see hello world being uppercased and put in the output destination. So again, for those of you who are familiar, you didn't see anything new. For those of you who see it for the first time, this is how simple it was for me from the, at least, development perspective to write a messaging app that receives the message, performs some functionality, and sends the message out using RabbitMQ. Now, with regards to additional configuration that I had here, first of all, no configuration was necessary at all to do that. I just did it for simplicity because right now, the queue became persistent because it's named. If it wasn't named, it would be anonymous. It would be just some hash, some gibberish name that would disappear every time I shut down my application. And that's usually not what you do in production anyway. So all I did is define the destination name, my destination, and my group. And if you look at my Rabbit, that's exactly what I have here. My destination, my group. So that's the name. And that's where that name came from. There is nothing hidden, so this is basically it. That is the application. Okay? So now, what if obviously this is, let's start diving a little deeper. What if I wanted to, I mentioned earlier about the content type negotiation, conversion, and so on and so forth. So I created this domain class called person, which again, it just has two attributes, ID and a name, right? So, and I'm going to change this, the input parameter for this method to a person, right? So now we need to fix a little bit of code, and so I'm going to do person that to string and that to uppercase. So now we're going to basically execute the toString on a person. So we're going to receive a person, and we're going to output the string, right? So that's all I did. I didn't provide any other configuration. So let's start again. Just purge what's out there. OK. So we're going to go again to this channel, and we're going to basically send name. I'll use SOBI and ID 1, 2, 3. So that's what we're going to be sending. Well, you just saw how error handling works. So hold up a second. ID. Oh, yeah. I gotta start wearing glasses. I'm trying to pretend that I'm younger. I'm not. So, all right. OK, now we got the message successfully. So I can go back, and hopefully it's already here. Get messages. And you can see we executed a string method which appended the name, the word person, and then uppercased everything, and so on and so forth. So how did it work? That's one of the things we it sort of existed before, but it was not very consistent. So one of the main sort of a theme and effort that we went with, that the framework underwent for the 2.0 release, was to simplify and make more consistent the type conversion. So basically, we from the community feedback, we recognized that application JSON is the most appropriate, the most useful default type. So in this particular case, you can provide content type through configuration, but in this case, because we send JSON, and because we defined the default content type as application JSON, it simply figured out, OK, I'm receiving a byte array. I have to invoke a method that has a person as a type. So how do I convert it? My default type application JSON. It goes. That's what the framework does for you. It goes, finds the appropriate converter, converts it for you, and everything works as expected. So that's one of the conveniences that you have. And like I said, we have there's a whole section on type conversion. So obviously you can define. We support multiple different content types, so you can use any one of those and override the default one. You can also, and the type conversion happens based on the message converters, which is a standard abstraction within Spring messaging module. And you can provide your own message converter if you have some type that we cannot convert for you. But our current stack for framework includes about 7 converters, and that handles, based on our experience, about 90% of the cases. But every now and then we'll have somebody asking how to write a message converter, and it's actually rather simple, and there's plenty of examples that do that. So what else is new in Spring Cloud Stream? So the polling consumer, I'm going to skip showing the polling consumer today, but I'm going to show you I wanted to show you some of the ops features that are provided by Spring Cloud Stream, like, for example, the new actuator endpoints for the binding control. So now you can actually you can envision your bindings right now through actuator endpoints. You can also influence the bindings through actuator endpoints like stop, pause, and so on and so forth. We're going to look at the metrics. That's basically based on micrometer. That's the kind of the one of the big difference between 1.0 line and 2.0 line, because we completely revamped. Because the boot switched and we switched to new metrics. I'll show it to you using just simple GMX meter registry. Native support for Apache Kafka streaming. So again, you can talk to Sobi, or you can just look at this presentation by Josh Long. How many of you know Josh Long? Well, who doesn't know Josh Long? Okay. So he has a YouTube video where he provides a good presentation on that. And so now somebody asked me a question like earlier in my previous talk about the footprint of the thing. So we are being cautious about this. So we made certain things optional. For example, I'm talking to you about the actuator and everything else. But if you don't need any of this and you don't need web, by default right now it's optional. So in other words, you have to opt in instead of opt out. So we deprecated some of the Java-based serialization. I can probably do another presentation just on that, why we did that. So just don't use Java serialization in distributed system, just whether it's a CRIA or pure Java serialization. And obviously, we revamped our user guide. So yeah, so it's much easier to navigate right now. So let's look at some of these features. Again, any questions so far? Okay. So my application is still running, so I'm going to, okay. Oh, I have to stop it. So like I said, I need to opt in for the actuator endpoints. So what I'm going to do, I have a little cheat sheet here. So I'm just going to do, in my properties when I start the application, I'm going to provide this property, right? And I'm going to start the application. And now I should be able to go actuator bindings. All of a sudden, you can see all the information about the bindings that currently is active. So you know, all the attributes, all the properties are now visible on the screen. Now, you can see some of the important ones I'll go through. So the name, the group name, pausable, I'll explain to you in a second what that is, and a state, it's currently running. So if I go to, so what am I doing? So can you guys see it? So basically, I'm executing a curl request to stop the endpoint. So now it's as if, so sometimes we kind of never had this capability to do it the sort of the simple way. So let's say you don't want to stop your application, you just want to stop the binding, stop receiving messages. So you just want it to temporarily, stop the message listener container. So you simply stop the binding. And you can see the message here is that stop the inbound channel and stop the inbound destination for RabbitMQ. And if I go back and refresh the page, you can see that it's stopped, right? And if I do the same and I can go start it, then it's been running again, right? Now, when it comes to certain message brokers, and one of them is Kafka, there's additional way of stopping, because in Kafka, stopping the binding versus pausing the binding are two different things. If you stop the binding, it may rebalance to different consumers, right? But if you pause the binding, you can simply hold the handle for that as a consumer. You just simply stop receiving messages, right? So now if I try to pause, for example, Rabbit, I'll see a log message saying that this particular binder doesn't support pausable, so no harm, no foul. Just simply saying the functionality didn't do anything to harm the system or whatever, and it tells you that what actually happened. So, but if it was a Kafka binder, then we would see that the binder, the system was paused versus the system is running and so on. So that's the actuator endpoint. So now you can see you can not only envision the binding, but you can also control the bindings and so on. So another interesting thing to look at. So I'm going to open Visual VM, and so what I did, so I told you about the metrics, right? So I included the metrics, one of the meter registry implementation onto my class path. So in this case, it's a JMX meter registry, and it's good for like when you're debugging or when you're just testing something locally. So I'm going to go into the mbeans, Spring integration. Here's my message input channel, right? And you can see, I don't know if I can increase the fonts here, but basically, okay, you can probably see. So right now it shows all the zeros. Right now, I'm going to go back to my Rabbit and let me just try to actually I'm going to send a bunch of messages, and now I can refresh, and you can all of a sudden see various different metrics information. So again, this is just an implementation of the meter registry. I didn't have to do anything to collect it. We already provide various different metrics collectors, and that's what's being sent there. That's already functionality provided by Spring Integration. We're just exposing it through Spring Cloud Stream. Now, the reason why I brought up metric collector is, or meter registry, is because what if you want to provide some, or monitor some of your own thing, like let's say the time-lapse execution of your method or something along those lines, right? So you can now simply auto-wire meter registry into your application code and start create your own meters and everything else, and then observe them in whatever metric collection facility you use. Now, it's also important to understand, even though it's completely outside of scope of Spring Cloud Stream or anything Spring Cloud, that meter registry is a composite component, which means that you may have JMX, you may have Datadog, you may have a lot of them there, and which means that a single metric event will go out to all of them, right? So as a developer, again, you don't have to know, you only have one single abstraction, and whatever is injected, whatever is auto-wired, that's sort of the benefit that you get from Spring and Spring integration with meter registry. All right, what else am I missing? So, all right, now I'm going to get to the real cool and interesting part. So, any questions so far? I mean, obviously, there's a lot that I'm kind of skipping because you can, we can have the entire workshop on Spring Cloud Stream and data flow and stuff, but I kind of covered the main parts, and I hope you got the idea of what Spring Cloud Stream is and what Spring Cloud Stream for. Now, the other thing I was going to mention to you is for those of you who are using Spring Integration, that's what I was trying to say, that if you don't, so Stream Listener is a native annotation that defines this method as a handler to Spring Cloud Stream, right? But if you already have a Spring integration or something like this, you can simply say service activator, and then input channel equals processor input, and the same goes for the output channel, and the same thing would work. You can rename it to transformer, filter, whatever it is you want to do. So in other words, those annotations will still work. So programming a model is whatever it is you want it to be, right? But it still kind of feels to me, when I sort of took over, it feels to me a bit involved, right? So let me get to the slides real quick. So this is what we're going to be talking about right now. So some of you are familiar with the Spring Cloud Function project, but I'm sure that most of you, if not all of you, are familiar with Java functions in general, right? So, and I want to kind of segue a little bit and talk a little bit about Java functions as basically, when I say Java functions, I'm implying supplier, function, and consumer, those three interfaces, okay? So if you think about it, it's like I wish we had them since Java 1, because those are the three most fundamental interfaces, because I cannot think of any use case in the past, currently, and in the future, the ones that I don't even know yet, that could not be mapped to either function, supplier, or consumer. In other words, think about this statement. It's very opinionated, but I'm basically declaring that whatever requirement you may ever have in the future can always be mapped to either supplier, function, or consumer. What it means to me is that I can build a framework, or I can work with a framework that only sees the world as function, supplier, and consumer. Because of that, you can only see a requirement as function, supplier, and consumer, and not worry about how this function, supplier, and consumer are going to be invoked. Right? You can test it completely outside of scope where it's going to live and where it's going to be invoked. Right? So now let's think about it in terms of these message handlers that I was writing. So isn't this really a function? Well, it's not written as a function, but let's try to rewrite it, right? So I'm going to do function. Uppercase, we obviously don't need anything like this here, and we're just going to do right? The same method, I mean the same functionality, but now written as a function, okay? And what if I just do this? So it becomes a bean. Why can't this function be invoked? So in other words, I've written a function, I've written it within my application, but it could be written as a separate jar and just dropped in the class path, and I just simply configure it here as a bean, right? But it's a function that takes string, outputs string. I don't really care whether you use some framework or don't use some framework. To me, it's a function. All I need to care about is, can I invoke this function within the scope of Spring Cloud Stream, for example, right? Or using some other invocation mechanism. So let's try. So I am going to, I'll define this property, and I will explain to you later in a second why do we need it, and oops, and what it's for. So, okay. So basically, everything remains the same right now, but our application configuration became a little simpler, so we actually don't need this. We already saw the bindings. Obviously, everything remains the same. So I'll explain to you in a second about this property. So we just simply define a function called uppercase. Again, we don't need to define even the name or anything. So basically, we expose it as a bean, and that's it. So I'm going to start it. And in fact, just so we don't have to keep going to the rabbit and checking, I'm just going to put a system.out@println here. Okay, so just a little more code just so we can see it on the console. Right, so I'm going to start it. And while it's starting, this basically property says that, you can have multiple, obviously it's a bean, right? It's no longer a stream listener or service activator or whatever. You can have multiple beans that represent the function. Which one do you want Spring Cloud function to bootstrap? And we'll talk about what that bootstrapping actually means in a few minutes. So, okay, everything started, so I'm going to go back to here, and I'm going to send a message. So we received Bob ID 123. So we received the message, but it's a function, right? But, just a function. Here's what else I can do. Oops. All of a sudden, I still have, it's the same function, but now all of a sudden it's being invoked as via messaging. It's also being invoked as a REST endpoint, right? All by simply dropping a order configuration jar that provides the invocation model for this particular, for the functions, right? So that's pretty much, so the idea is right now is that why write stream listeners or service activator? We're trying to simplify the programming model, programming paradigm for the developer and say, listen, if you only live in a world of function, and by the way, the same applies for the supplier, consumer, and supplier, consumer, and function. So now you can simply develop a functions and then based on the order configuration components that you have within your class path, those functions are going to be invoked on a variety of different, or via a variety of different mechanisms, like in this case, messaging and REST endpoint. So now the same thing that I was telling you before, if I wanted to do a type conversion, then I can just say and obviously the same thing will work. So the same semantics are working. And again, I don't have to do anything. This is a lot of this functionality comes from Spring Cloud Function. Why did I put debug? I didn't want to do that. A lot of this functionality comes from Spring Cloud Function, and we simply just provided a very thin layer to integrate Spring Cloud Function with Spring Cloud Stream. Right? Again, where's my rabbit? So again, received person 123/Bob, right? So the type conversion happened and everything else happened. Now, this is where it's going to get more interesting. So one of the sort of a downside of, and again, I want to be very careful when I use the word downside. When you, obviously, as I mentioned before, in Spring Cloud Stream, you're using Spring integration. So technically, you can define a stream listener that receives a message from one channel and sends to an internal channel defined within your application. So now you can build the entire Spring integration workflow within a single application. But that also means that you're going to be sending messages to a variety of different channels using the dispatcher mechanism. And in a high throughput application, that may not be what you're looking for, right? You might want to speed things up a little bit. So function allows us to do functional composition. Right? For example, it's not even Spring Cloud Stream or Spring Cloud Function. It's just pure Java API. Like I can do, say, function and then or function.compose. Right? That's the operators that are provided by Java API. Right? So obviously, I can define a bunch of functions and use those operators. But I don't even have to do that. So I can actually, here's my other function that I'm going to expose. I'm going to skip the flux for now. I'll get back to it, right? I should have reverse. So we're going to do. So basically now I have, if you can see, I have two functions, right? So technically I can create a third bean and say, create me, expose it as a function and basically do uppercase and then reverse. But the beauty of Spring Cloud Function is that Spring Cloud Function provides a DSL that allows you to achieve a certain level of composition, right? And the reason why it's important is because that means that you, at the deployment time, let's say you have a jar full of functions. They're all going to be loaded into the Spring Cloud Function registry, but based on your deployment instruction, you can say, I want this function to be composed with this function, to be composed with this function, and exposed as a message handler. So all I need to do here is say uppercase, pipe, the same, in fact, the same DSL, the same, for those of you who are familiar with data flow, kind of the same mechanism and the same semantics that we use in a data flow to pipe different components together. So reverse, right? So now we're going to execute. Basically, what this instruction does, it creates a composed function that essentially creates a pipeline where the first is going to be uppercase, then it's going to be reverse, but internally it's going to use the Java function native mechanism to compose these functions into a single function, and now it's as if you had a single function, right? So again, we're going to so received oh, of course. We need to go to now Rabbit because I didn't put a system.out line. So queues. And I didn't purge. Where's my last message? Yeah, you can see. It's been uppercased and reversed, right? So that's my last message. So all of a sudden, I just, again, living in the world of functions, just writing simple functions, and all of a sudden, I'm invoking it through a messaging systems. Okay? Now, questions? Say what? How do we call it as REST? You just simply well, with REST it's a little different right now because you have to provide different configuration because you can call this function by name or this function by name, right? So I was just showing you that there is different mechanisms, so I have to do a little bit of a bootstrapping to invoke it in a composed way via REST. But anyway, yeah. So all right, so yeah, go ahead. Absolutely. So I just, you mean like this property? Yeah. So the question is, can this property be configured in the YAML? Absolutely, yes. Right. And that's this is a demo-friendly way, but yeah. But of course, it's a property, just any other property. Any other questions? Yes.
It's still unclear to me how that parameter caused the rabbit message to go to the composed function. Like, I don't see how that glued together at all. It's like, I mean, it's magic. Framework, but not following.
So the question is how this function was bound to. So within Spring Cloud function, we literally assume single input, single output. So remember how earlier I said about that my vision of microservices do one thing and one thing well? So for me, this microservice is a function. It exposes a single function, it exposes a single input, which means I already have defined a enable binding processor, which means I have an input channel and an output channel. Those are, in fact, just so you can see how that comes about, I have a processor, which is the source and the sink, and this is where the input and output is defined. Okay? So, oh, God. This is something I didn't want to happen. So I need to, I don't know how to change it, it's just Eclipse, so I'm going to actually kill it, force quit. No, I never, like, it just, one single move and all my windows got changed. The best way for me right now to just like kill it, and because it didn't save it, so give me a second. It only happens in a demo, you know that, right? And now I have to switch to workspace because I just clicked on the wrong one. All right, so yeah, basically, so the processor stereotype defines input and output channel, and I'm assuming that whatever function you decide to bootstrap through function definition is going to be bootstrapped to input and output channel, input for the input. So that's implicit. That's like a default, right? So that kind of like preempts another question. Can I have multiple listeners within a Spring Cloud function model? Currently, no. We don't support that, right? And I'm sort of against that because I'm like saying, I'm not here to show you how to build messaging application that accepts multiple things. We're considering it. We're talking about this. But at this point of time, it's a single input, single output, or single input or single output, depending on whether it's a. So does that answer? Yes. OK. All right. All right, hold up a second. I need to switch. All right. Anybody else? Yes?
So when you configured both functions inside there, it went from the first one picked up from the queue, and then it went into the second one?
Yeah, because basically what I did is effectively, actually, I was in the right workspace, sorry. So what I effectively did, if you're familiar with the Java util.function API, I did function and then function and then function. And the output of that composition is a single function that already consists of 2, 3, 4, however many you composed. So it's just that I could have done it that way for simple functions, but I'm about to show you something really cool where I couldn't have done it in a simple way, but this is like a benefit of what additional benefit that Spring Cloud Function provides. Just give me a second. So what I was saying is that let's pretend I had public void foo, just so we're on the same page. So I could say this dot to I'm sorry, not to uppercase. Uppercase dot end then reverse, right? It would be the output of this. Obviously, it's not a void, but the output of this would be a function that receives a person, outputs the string, but the function itself would be a composition between the two functions, right? So I just did it through DSL, thus allowing you to do it to make the decision. So the benefit is not only that I can do it in a configurable way. The benefit is that I can defer that decision till the deployment time. Hence that question about whether it could be sticked in a YAML or provided from a command line or whatever. So picture you have library functions. You can actually build something simple. You can actually build your sort of a functional pipeline just from a command line. Yes?
Can you update it using, can you update the function using the refresh scope, using actuator?
Not at the moment. It's a new functionality. Can I update the function using refresh scope? I would suggest you raise the issue in the GitHub because it's a very valid point. At this point, you have to, yeah, please, because it's a relatively new functionality, but it's, any other questions? Yes?
How do you write the test? How do you write the test to test this pipeline?
Oh, you don't have to write the test to test the pipeline. You just simply write a test to test the function. That's one of the beauty of writing it as a function because the function itself is self-contained. The Spring Cloud Stream and Spring Cloud function provides the capability and the invoker, so to speak, to invoke this function. But for you, the developer of the function, you should only treat it as a function, nothing else. So you write a simple test where you invoke function by passing a person or a string or whatever it is and evaluating its output. You don't need to test because that would be called an integration test. And because we provide you this level of contract and guarantees, that's our problem. So if something doesn't work, it's not your problem, it's our problem. Complain to us, we will fix it. So that's why I'm saying you write functions, we'll take care of the invoking, transforming, converting, and doing all that stuff. Yes?
So those functions, it's not a view of functions. They live inside this.
No, it's the java.util.function. Yeah. Yes?
I was trying to understand what's the difference between if I use reactive queues or RabbitMQ. What's the advantage of that? Should I move to that or should I stay here?
I'm not sure I followed the question. Can you try?
The reactive execution queues, right? So I can do queues over there too, right? And do the listener pub sub. So why do I need to use this if I can do that? What's the advantage of that?
Advantage of using reactive queue versus. Well, I mean, I don't think it's really about reactive queue. It's really more about programming model, which I was about to get into, reactive. So in other words, one thing that I didn't mention is that everything in Spring Cloud function, every function is converted to reactive function. So basically, your function string become function flux string, right? And I'm about to show you. So maybe that will answer your question. So because when you said queue, whatever, to me, the framework already disconnected me from it a while ago because to me it's just a destination, right? So reactive, non-reactive, the real question is the programming model. Can I use one or the other one? And maybe that's my previous implementation of the method gave you that idea. So yeah, let's dive into that a little bit. So I'm going to actually remove this and expose this. And change it back to Flux. So how many of you are familiar with the reactive project reactor? Oh, I'm asking questions, not looking. Sorry about that. So okay, some of you, but so there's there are different programming models right now that are becoming somewhat popular. And like I mentioned, showed you before, the streaming. This monadic style where you define a sequence of operators and which describe your sort of a pipeline and so on. So, and you can kind of look at everything happening in a single environment, sort of in a single definition, kind of like a pipeline and so on. So basically, right now I have one function, uppercase, written sort of in an imperative way, and now we have this function that written in a reactive way. So actually, even though I mentioned to you that every function that you write is going to be converted, if it's a non-flux function, it's going to be converted to flux function internally within Spring Cloud function. Again, you don't have to worry about that. It's internal implementation, but you'll understand in a second why we're doing that. So in this particular case, I deliberately chose to write my function using reactive approach. So now I can actually say, OK, I want to print the input, then I want to reverse the string. Okay, and I can continue to do map, which is basically transform, and so on. So I can write the whole pipeline, and essentially what I'm exposing here as a function, not a handler that will receive one string at a time. I'm essentially creating a streaming pipeline where I can define. So it's a different programming model. The result is the same, but the programming model is different. And what we're saying here, okay, well, you're the new guy, you're the young guy, you prefer the reactive approach, go ahead. You can write a function using reactive API, and for us, it's the same thing, right? Well, what about uppercase pipe reverse? Because one function is written in an imperative way, and one function is written in a reactive way, right? Well, this is where doing uppercase and then reactive, and then reverse would not work. But that's where, again, the framework like Spring Cloud Function provides you the capability to do just that. Why? Because while I cannot do and then between current version of uppercase and reverse, because internally everything is converted to this canonical representation of flux, string, or basically function flux, then we can do this composition, right? So it becomes, so now, because of that, we can now actually give you the flexibility to choose the programming model that you want. So again, I'll try to run it. Oh, errors in the project. What is it complaining about? The lambda expression. Say what? It's not important because it's in the same package. It's, yeah, it's maybe one of those. No, here we go. You know what? And it's like, everybody's like, some of these guys are going to say, switch to IntelliJ. I tried. I just, like, I guess I'm too old. It's not going to happen. I do have IntelliJ. I use it for some things, but just not going to happen. So anyway, I'm just so committed to Eclipse. I've been using it for like, I don't know, I think since it came out, like back in like early 2000s, before it was actually useful. So, all right, let's just send, well, let me just purge it because this is just purge, okay. So queues, we're gonna send a message. Yeah, I saw that. All right. Yeah, so we got the person, sorry, Glenn, username. Yep. So, and so basically now here's an example that allows you to see that if you prefer to use reactive programming model, not only you can use it, you can also combine it. So in other words, you can choose which programming model you want to use to implement those functions because Spring Cloud Function will be able to compose and integrate either one of them together, right? So we only have 5 minutes or 4 minutes left. So again, questions? Now I have a question. How many of you, well, we'll get to that. How many of you, one question I didn't ask, how many of you use Kotlin? So good. So there's, 8 people. Which is good. How many of you use Scala? Wow, still do? All right, I'm not going to say anything, but other than move on. So Kotlin is, I just started learning Kotlin. I'm pretty impressed with the language, the features, and what it gives you. We had an issue that was one of the most popular issues in Spring Cloud Function to provide Kotlin support. And although I'm not going to provide an example right now, I just ran out of time, but we just released Spring Cloud Function with Kotlin support, which means we support, in Kotlin there is no it's a obviously different language, so there's no consumer and supplier. There is function 0, function 1, up to 22 or 23, something like that, right? So, but which means that function 0 is consumer, function 1 is, no, function 1 is the consumer or supplier, depending on how you rate it, and function 2 is basically a function, right? So anyway, the point is that you're writing it as a lambda. You're not even writing it as a function. So it's completely, in Kotlin, completely transparent to you. But the point is that if you write something, basically it's how many are familiar with the concept of a duck typing? So in Kotlin, if you write a lambda that fits either consumer, supplier, or function, it's as if you've written, and annotated with that bean, it's as if you've written a function in Java. So in other words, again, we'll convert it, we'll transform it. So again, as now outside of just writing reactive or non-reactive, you can also use different language if you prefer to. And because it's a Spring Cloud Function feature, now because Spring Cloud Function is a dependency and used by Spring Cloud Stream, that means that you have all these different ways you can write those message handlers and obviously do your streaming applications. And then deploy them in Spring Cloud Dataflow. I am done. Questions? Oh, yeah, POM XML, yeah. So let me quickly review what's in POM XML. That's a good question. Thanks for reminding me of that. Because it's interesting that a lot of the trickery comes from the POM because a lot of this is through auto configuration. So in other words, your code is very simple. There's not much going on in the code, and most of it is going on in auto configuration provided within those jars. And okay, I don't know why I cannot increase the font. So basically, here's the important part. Spring Cloud's, oh, I didn't show you the testing. So this is, I'm going to skip this segment. It's the test binder, but since I didn't show it to you, there's nothing to discuss. Micrometer, remember when I showed you the micrometer, the metric meter registry? That's basically, I added that. Now I can do GMX. If I just remove it, that essentially becomes optional. So I'm going to start actuator. That becomes optional. If you don't want actuator, you can just remove it. So this, like I said, you have to opt in, right? If you, in this particular case, if you don't want web, it's optional. If you don't want functions to be exposed as a REST endpoints, this is optional. So all of a sudden, the only thing that is not optional is AMQP because I'm using Rabbit and Stream. And actually, even this is optional just because this will pull the other one transitively. So essentially, you only need these two. I was going to say this is optional, but that's just the same as saying tests are optional. Tests are not optional. So okay, how does it know what the Rabbit configuration is? That comes from Rabbit auto configuration because in Spring, we're famous for arguing, fighting, and then defining sensible defaults. So by default, it's going to look for Rabbit on localhost. What's the port, Artem? 672. 5672. Right? That's how it knows. And if you don't like it, then there's a configuration to say point to this host, this port, and so on and so forth. And the same goes for Kafka and others. So there's a default broker, kind of a known thing. So any other questions? Say what? MQ, which MQ? MQ series, which is basically the infamous JMS question. The problem is that there are efforts out there for a variety of different JMS binders. The problem is that JMS was never portable. So it's IBM MQ, WebLogic, or ActiveMQ, or whatever, so because everybody has their own extension. So right now, there is a binders out there somewhere. Some people kind of make them work. The short answer, we do not support it. Yeah. We've been considering for the past year and still considering. So, I mean, the question does come up, but not as, it's not as high in the priority within the list of other questions that come up. So. However, as Artyom says, pull requests are always welcome. So.
The Java serialization is being deprecated. What's the alternative for that?
Anything else, like like JSON, Avro, anything but Java. Java serialization, the simple answer is this: how in a distributed system can you guarantee that the type is present on the remote system, and can you guarantee that the version of JVM on the remote system is the same as on this system? That's a simple answer. So if you're building a distributed system, you cannot be doing this type of level of coupling. So Java serialization is just the evil. Not to mention there are security risks with that as well, which I can share in secret. It's not with security risk with us, it's just with Java serialization, because there is one very little known feature with Java serialization where you can actually, like, usually the type is expected to be present, so the definition is loaded once the serialized stream arrived. But you can actually transform the type too. You can override a class loader, specific class loader, and transform the type. And if you have that class loader on the class path that will look for the type inside of your stream, then you can actually pass completely executable stream, the completely rogue code that will load itself and execute. So it basically depends on the remote class loader. If that class loader overrides that one method, that pretty much whatever it is you write in the code that you pass is going to be executed. You know, like moving those decimal points in the bank transfers. Office Space? Too old? Guys, thank you very much.